Why AI agents forget? You've probably seen this happen with AI agents or even AI chats. You explain your project, you give your limitations or what kind of considerations that it needs to make. Then you talk with your agents, and for some time while you are chatting with it, it feels like it understands what you want. But then a few messages later, an important detail that you really wanted it to remember, it's gone. For example, it ignores your coding style, or it repeats a step that has already been done. What you feel is more like the information existed somewhere, but your agent failed to bring it back at the right moment. This usually is typical memory problem, and this becomes much more serious once you want to build a big program using agents, because an agent is supposed to work across multiple steps. It needs to remember the current goal, what already happened, which tools failed, which assumptions were made, and what should happen next. So the real question is not can your agents remember? The real question is how can we design the memory for the agents to remember it at the right time? We try to address that in this video, because memory in AI agents is a system design problem. The first thing to understand is context is not the same thing as memory. A lot of AI systems like chat or agents creates the feeling of memory by replaying the previous conversation history back to the next prompt. The model that you are chatting with is not really remembering, it's rereading. So you may see in your projects for short conversations that works fine, but agents are different. Agents create plans, they call tools, and they retrieve failed operations and revise earlier decisions. Once tasks become long enough, replaying more and more history into the prompt starts breaking down, because now the model is reading everything, basically all the garbage information that are already included in those prompts, like all instructions, failed attempts, temporary reasoning, outdated outputs, and random details from alias steps. Somewhere inside all of this garbage is the one detail that actually matters right now. People often think the model forgot, so we need a larger context window, but they do not organize the information. They make the room bigger, but they don't clean the room. For example, when you want to debug a backend service with an autonomous agent, the agent checked the logs, verified the API response, retried one failed request, and narrowed the issue to a parser. Now imagine the system loses that workflow state. The agent may repeat the exact same investigation again, not because the reasoning failed, because the state disappeared. That's a real memory problem in agents. Usually it's not about facts, it's about continuity. The agent needs to know what has been tried, what failed, but is still open, and where it currently is in the workflow. Without this information, agents can look productive while going in circles. You see a lot of thinking, a lot of output, but no meaningful output. This is why better memory does not always mean more memory. Sometimes it means less information, but better selective. One example is customer support agents. The agent probably does not need every conversation the customer ever had. It mostly needs persistent preferences, unresolved issues, maybe some account-specific constraints, and recent context. Everything else can become noise. You can also see this in Mem0 paper, which basically reported that with selective memory execution, you can reduce large token and latency, which in recent time, especially tokens that are costly, and you want to use them as efficient as possible, unless you have unlimited access to Cloud Code, Codex, or any other agents. A better approach maybe we can do in this is that we do not store full conversation history forever. We can extract maybe useful long-term information. So the design principle or design rule here is simple. Store what remains useful, not everything that happened. As simple as that. Some details matter only for the current task. Some should disappear soon. We need some information survive across different sessions, or some should never come back again, and we want to simply delete them. This is why agent memory usually needs layers. Working memory handles the current task, the active goal, completed steps, failed tools, the current hypothesis, and so on and so forth. This is what stops agents from repeating themselves. Imagine an agent or coding agent fixing a failing issue or fixing a bug, and the bug is simply coming from the package installation failure. And if the system forgets that this package installation already failed 3 times, it may retry the exact same command repeatedly. And be careful, this is not because the reasoning is bad, it's because the workflow state was lost. In the long-term memory, we can store preferences, project knowledge, historical outcomes, and stable patterns. This is what allows continuity between sessions. But long-term memory should not become a giant archive of everything the user ever said. That's how systems become noisy and produce a lot of garbage. A good memory system is selective. Not every sentence should be kept. Not every failed attempt should be remembered forever. Maybe you keep some of the failed attempts just to avoid the agent to repeat the same mistakes. But you need to be careful because the failed attempt itself needs to be handled in a way that agents doesn't use it as a reference. And this is the difference between memory and hoarding. So one practical rule is simple. Do not make your agent remember everything. Make it remember what stays useful. But storing the right thing is only half of the problem. The next failure happens during retrieval. Even if the system has useful information, it still has to decide when to bring that information back. Some systems retrieve aggressively. That can help sometimes, but it can also hurt. Because irrelevant retrieval creates distraction. Suppose an agent is writing SQL queries for an analytics dashboard. Pulling in unrelated memory from older front-end discussions may actually reduce the performance because the model now has a separate relevant schema information. This has been discussed in the self-reg paper, which shows that adaptive retrieval improves factuality over always retrieved systems. Sometimes the best memory decision is nothing from the past is needed right now. Be careful, that's not forgetting, that is restraint, because memory is useful only if it improves the next decision. If the system only makes the prompt bigger, it's not memory, it's basically clutter. This is also why state matters so much. State means the agent understands where it is inside the workflow. For example, in your system, one test failed and one dependency was missing. And the current hypothesis is that the bug is in the parser. This whole story is a state. Without a state, agents become unstable. They retry the same failed command, they repeat the work, they lose track of the progress, and they become useless. Because the agent can call tools and make plans. But if it doesn't reliably know where it is right now in the workflow, its workflow will collapse. And that's not a language problem, it's a state management problem. So if you are building agents, track workflow state explicitly. Do not hide everything inside conversation history. Because if the only record of progress is buried inside a giant transcript, the agent has to reconstruct the workflow every time it acts. And reconstruction is fragile. As your agents run longer, memory also needs compression. You can't keep every detail forever. Recent actions, for example, can state details. Older interactions become summaries. Repeated observations become higher-level insights. Instead of storing 10 moments where a user asks for simple examples, the system may store like this. This user prefers concrete examples before abstractions. This is shorter, cleaner, and usually more useful than raw logs. Forgetting matters too. A good memory system needs deletion. It needs expiration and updating. If a user changes their preference, the old preference should not keep returning. If a task is finished, temporary state should not influence the future workflows. Memory is not just adding information, it's maintaining information over the time. So if you are building agents, the goal could be that building an agent that remembers the right things, forgets the right things, and knows when memory should influence the next action. Do not rely only on larger context windows. Separate working memory from long-term memory. Track workflow state explicitly, retrieve selectively, summarize older information, store insights, and test memory over long-running workflows. Because memory systems often look good for 5 minutes and become unstable after 50 steps. So if you are watching the video until now, first we would like to thank you to become our community. And we would like to give you a small teaser for the next video. We are currently developing an open source application which we call it AgentCrew, to make sure that we can develop our personal projects using that open source project. In the next video, we would like to share it with you, and you can use the tool and give your feedback to us, how we can improve it. It's basically a markdown-based tool which you load into any other of your agents and make sure that the process of software development goes through what has been defined in AgentCrew. We try to make it in a way that is ideal for us to develop a project, and at the same time, we would be happy to use your feedbacks and your experience to make it better. There's a link in the description to the project which you can test before the next video comes, since you are our champ. So, as always, until the next video, good morning, good afternoon, good evening. Bye.